everyone. Today we're going to do a demonstration involving a light bulb to basically see what types of things can conduct electricity when dissolved in water. Now the first thing you need to understand about my light bulb is that none of these things I'm going to test are creating electricity. The light bulb is plugged into the wall just like the lights are at your house. The light bulb itself doesn't come on when it's plugged into the wall because the circuit isn't complete. There are two sides to this thing, right here, and the two sides aren't connected. But if I connect the two electrodes of this thing using a wire, just like the wiring in your house, the light bulb will light up. So what we're essentially measuring is whether the things that we're going to put the electrodes of this light bulb into have the ability to complete the circuit. When I do this, I'm serving basically the function of a light switch. In your house, when you turn the switch off, the switch disconnects the two sides of the light bulb, and when you turn the light switch back to on, it connects the two sides of the light bulb. So I'm going to take the wire off, and we're going to use the light bulb to check whether different things will conduct electricity or not. So the first thing we need to do is to get a baseline. Because we're going to be dissolving things into deionized water, we need to know whether deionized water conducts electricity or not. So we'll put the light bulb there where you can see it. This is just a beaker of deionized water. Contrary to what a lot of people believe, water is not actually a very good conductor of electricity. You can see that the light bulb does not come on when I dip the prongs into deionized water. Now what I'm going to do is take a number of compounds, and I'm going to check those compounds to see if they conduct electricity in both the solid form and when dissolved in water. So our first compound is sodium nitrate. Sodium nitrate is just a white powder. Around the house you'd say it looks an awful lot like table salt. And you can see that if I put the prongs of the light bulb into the sodium nitrate, it does not conduct electricity. Next, I'm going to take a beaker of deionized water, lower the light bulb prongs into there. You can see that the deionized water still doesn't conduct electricity. However, if I take a scoop of the sodium nitrate and put it into the beaker of deionized water, stir until it dissolves, dissolving of the sodium nitrate will cause the deionized water to begin to be able to conduct electricity. So I'm going to return that to over here. Unplug my light bulb so I can clean off the prongs. And for the rest of these, I have the solutions pre-made so that we can do this a little bit more quickly. The next compound is copper 2 chloride. Copper 2 chloride is kind of a turquoise powder. And just like the sodium nitrate, the powder itself doesn't conduct electricity. However, this one also helps deionized water conduct when it's dissolved in water. Cleaning the electrodes again. Our next one is sucrose. Sucrose is just sugar like you'd put maybe on your cereal or in your coffee in the morning. Solid sucrose is not a good conductor of electricity. And as you can see, neither is a sucrose solution. So sugar water doesn't conduct electricity. Related to sucrose is a molecule called dextrose. Dextrose is a simpler sugar. It's used in IVs for people who are in the hospital, and this is also the sugar that your blood has in it after your body breaks down food. It's a little bit finer of a powder than sucrose, but still a white powdery substance that doesn't conduct electricity. When dissolved in water, dextrose does not help the conductivity as well. Our next compound is going to be sodium chloride, or table salt. like most of the others, or like all of them so far, table salt does not conduct in its pure solid form. However, a solution of sodium chloride, or salt water, is an excellent conductor of electricity. The next compound is urea. Our sample of urea happens to be kind of a white substance made of little spheres. A lot of people, when they see it in lab, say it looks an awful lot like Dippin' Dots. And here is a beaker of urea water, and it fails to conduct electricity when dissolved in water. Our next compound is potassium carbonate. Visually, white powder again looks an awful lot like table salt. Doesn't conduct in its solid form. However, when dissolved in water, potassium carbonate is quite a good conductor of electricity. Next, we have sodium hydroxide. Sodium hydroxide is kind of a series of lumps. When they sit out, they get a little bit sticky because they absorb water from the air. But the lumps themselves aren't good conductors of electricity. However, when you dissolve those lumps in water, when dissolved in water, sodium hydroxide conducts rather well. Our next one is a liquid in its pure form. This stuff is isopropyl alcohol, or isopropanol. It is the active ingredient in the rubbing alcohol that you might have in your cupboard. Rubbing alcohol is a 70% solution of isopropanol, but this is pure isopropanol. And in its liquid state, isopropanol does not conduct electricity. When dissolved in water, like it is in the rubbing alcohol in your house, isopropanol remains a relatively poor conductor of electricity. So that rubbing alcohol solution in your cupboard would not conduct electricity. The last one is simply a piece of copper metal. In its solid form, the copper metal can be used to complete the circuit, much like a light switch can complete the circuit. However, if I take the piece of copper and I throw it into a beaker of deionized water, as long as I don't touch the prongs to the copper, having the copper wire in the water doesn't help the water to conduct electricity. Now, unlike our other things, the copper won't actually dissolve in water. But I did want you to see that adding a piece of copper or any other metal to a cup of water, as long as the prongs aren't touching that metal, that doesn't improve the conductivity situation at all either.